All right, here we go. So if you want to do secant on your calculator, there is no key for that usually. I mean, it might be buried on a TI or something, but so usually what we do is we do the reciprocal function. And remember, it's the ratio that flips. We never flip angles, right? We never reciprocate an angle. That wouldn't make sense. So you would find the cosine and flip it. Now, if you're on your calculator, make sure you're on degrees. So on this calculator, I would go to mode. Right now I'm on radians. Okay, so I'm switching it to degrees. And then if I want to find the secant, I would do 1 divided by cosine in degrees of 52, and I would get 1.6243. Okay, all right, here, how would you draw 425? Well, you'd rotate 360 and then another 65. So that angle would end up ending right there. Okay, a coterminal angle would be take that 425, subtract 360, and keep subtracting 360 till I get negative. So if I start here and go negative 180 and another negative 95, I'll end up at the same place. Okay, with radians, if I cut my pi, which remember this is pi, cut it into 5 pieces, right? Going down pi over 5 would be that radian. And again, you could add 2 pi over and over again. That's the same as 360. Get a common denominator because we're doing fractions. A -1 and 10 would give you 9 and then over 5. Okay, so 9 pi over 5. Converting, I have degrees. I want to cancel degrees, so do dimensional analysis, put pi over 180, cancel, simplify. Here I have pi on top, which means I'm in radians, right? The only time you have to write the word is if you're like 3.79 radians, because people might think that's a ratio, like we can't tell, right? That's an angle. But if you have a pi in it, like pi over 2, we all know that's an angle. So here we have radians, we put pi on bottom to cancel 180 in the numerator. And again, just multiply these. I would multiply, hit enter, then divide by 8. And I got that. All right, this guy, definitely not on the unit circle, so you know it's a bow tie. That goes with Pythagorean theorem, SOHCAHTOA. So where are we at? Quadrant 4. All right, so I make my bow tie. Sine is opposite over hypotenuse. And so this vector is going down. Hypotenuse can never be negative. This vector is going to be positive because it's going to the right. This is a Pythagorean theorem where you subtract because you know the hypotenuse, you know C. So you get a squared plus b squared equals c squared, subtract, and you get the square root of 21. Okay, cosine is SOHCAHTOA, so adjacent over hypotenuse. And that makes sense, it's positive because cosine, you know, x values are positive up here, positive down here. Tangent is SOHCAHTOA, opposite over adjacent. And again, we don't like leaving answers. I don't know what Newton or my math club does, but we usually rationalize them and get that. And that makes sense. It's negative because this would be what? A positive, negative. Positive on the x, negative. So tangent, cotangent, and stuff should all be negative. All right, next page. Again, -1, -6 is not on the unit circle. So this has to be a bow tie problem. I'm asking you for ratios. Go back 1, go down 6. These are like vectors again. So they have direction and magnitude. With Pythagorean theorem, this time I know A and B, so I'm not going to subtract. I'm just going to end up adding and getting C. Excuse me. Can't get negatives in here because a negative times a negative is a positive. Negative times a negative is a positive. Square root of 37. All right. So then I go do my ratios. Sine is, so this is your SOHCAHTOA part, opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Now, I would rationalize these, but before I do, I would reciprocate because these are your reciprocal functions. So before you make it pretty, go ahead and flip it over because this guy is nice when you do that. So, and can't put negatives in the denominator, so you just push it up there. Same thing here, flip it, do the reciprocal, and then we don't usually write the 1, and again, the negative goes up there. This guy, negative divided by negative is a positive, and then just go ahead and reciprocate or flip it, you get that. So this one I'm gonna make pretty, square root of 37, square root of 37. So -6, square root of 37 over 37. Okay. All right. Next one. Okay. So I give you the formulas. This is arc length. I drew a really bad picture there. So anyway, here's the swing of the bat, right? If you use a trig formula, you need to remember that theta is always in the radians. Okay. And they went feet. So I went ahead and divided by 12 inches and converted to feet in the get-go. If you do it after the fact, you're going to have to divide by what? 12 inches at the end, because 12 inches in a foot. So I converted the angle into radians and then just took that big long decimal times 4, and I got 18 feet. Now, if that doesn't make sense to you, you can view it as a percent of circumference. Clowns get pied in the face, circumference formula, pi times d, and then you just want a percent of it because you only have this angle of it. So the whole is 360. So you have part out of the whole, that's your percent, times pi times the diameter, not the radius, and you'll still get the same answer. So depends on which one you like better. And then same thing for area of a sector, okay? If you use the formula I gave you, you have to convert into radians. So again, 245 pi over 180. Again, I just multiply, enter, divide, get that. Take all that ugly decimal times radius squared and times a half or 0.5. And I got that answer. Now, again, if your brain doesn't like that, you could just do a percent of area. So here's the fraction out of 360. That's your percent times pi r squared. Still get the same answer. Does not matter. Okay. Story problems. What I like to do is figure out, first draw a good picture. We have to have a right triangle because we're doing trig. And we want to know the distance in the air from the point to the airplane. Now, notice we don't care about the adjacent side. So right away I crossed off tangent. Okay. Because I actually have the hypotenuse that I care about. So I know I have to either be doing sine or cosine. Well, look at what I have. I have the angle. I have opposite, so using cosine is not going to help me. So I know that I want to use sine. So I take sine of 23, opposite over the hypotenuse, and I like to cross multiply arm proportions. So I take the 1 times 1200, that's there. Take the d times that, there. Divide both sides by sine of 23 because I want to solve for d, right? I want to isolate, and the way you get rid of multiplying is dividing. So take 1 times that, divided by that, and I got that many meters. Okay. All right. The next one, you can use your unit circle on the, cheat sheet or whatever. So sine of negative 120. Okay. So what is this? This is a negative 90. So you'd be going another negative 30, right? So we'd be landing here. So I know my cosine and sine, alphabetical, they want sine. So I would be negative in that quadrant because, again, I'm going backwards. And there is technically a bow tie here. We just don't draw it, right? I'm going back and down, okay? All right, the next one, tangent of 90. Okay, so 90 is right up here, 0, 1. Sine, this is always cosine and sine, alphabetical. Tangent is sine divided by cosine. That is undefined. I heard a teacher once say it's okay. 0 divided by a number is okay. A number divided by 0 is like a knockout. You can't do it. So that guy's undefined. Okay, 7 pi over 6. All right, pi is over 6. 1, 2, 3, 4. What is it? 5. 6 pi over 6. 7 pi over 6 is right here. Okay, you skip your 45. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. We're right there. All right, and then what do they want? They want cosecant. So that would be the flip of sine, right? Alphabetical, and then C goes with S. So I'd flip a negative 2 or negative half. I get negative 2 is a reciprocal. This guy, I don't have tangents labeled on these. It would be a good idea to do that. So 5 pi over 6 is right here. Okay, so there's my 5 pi over 6. And so I went ahead and did tangent because I didn't have it labeled. So tangent is sine divided by cosine. But remember, you multiply by the reciprocal. So I'm going to flip that guy, 2 over negative square root of 3. So the answer would be 1 over the negative square root of 3. Now, normally I would rationalize that and make it all pretty, but I don't want the tangent. I want the cotangent. So I'm going to just reciprocate that or flip it, and it's all going to be fine. So I get a negative square root of 3. All right. So 80% of trig tends to be problems that are in the unit circle. So knowing the unit circle is super helpful. And then if you're dealing with ratios that are not on the unit circle, so it's not square root of 3 over 2. It's not a square root of 2 over 2. Things like that, those end up being your bow tie problems. All right. I think that's it. All right. Very good. Study hard. Good luck on the test. And